Is smelting concentrates worth it? And how much gold needs to be in this gold pan for me to make money today? Let's smelt this down and find out. If the test smelt works, then we're gonna scale up the whole operation. We'll shake it up and get it in the furnace. Let's see. I can tell you right now, I wouldn't smelt anything less than about 1 gram of gold per kilogram of concentrates. Not too long ago, Harry from Mine Operator, myself, along with Pete and some other YouTubers, went up to the Golden Griffin mine. We mined some ore, we brought it back to the shop, we crushed it up, we smelted the concentrates down, and got some really nice gold from our week-long trip. The stuff I have today is the number 2 concentrates. We've panned out most of the gold, and we're also gonna play with some of the number 3 concentrates to see if there's still enough gold to make it worthwhile to get it out of the leftover black sands. First thing we're gonna do here is do a little test smelt. I did one at the end of our last video and it came back pretty good, but this stuff's been sitting around a little bit. I gotta get it crushed up so the flux can interact with all the particles, and we'll do a little test smelt. And if the test smelt works, then we're gonna scale up the whole operation and do just a couple of bigger smelts and try and get this gold. Let's see how much material we're working with here all together. Okay, a little under 2 kilograms. Because this stuff is concentrates off our shaker table, there's gonna be a lot of sulfides in here, like galena, chalcopyrite, and iron pyrite. To get a successful smelt, we gotta get rid of all that stuff and get it into a form that will be soluble in our slag. So I'm gonna mix up a flux recipe that will do just that, so we'll end up with a metal button at the bottom and slag on top. So let's measure out 500 grams. Seems like a pretty good number. So there's 500 grams of concentrates. Now I'm gonna mix 500 grams of soda ash, and this is going to make a basic slag that will help absorb all the iron sulfide that we're gonna make. So 1 part cons, 1 part soda ash. Oh, it's gonna be perfect. Almost. There we go. Pour that in with our cons. Now we're gonna add about 175 grams of silica sand. And silica does a great job of absorbing any metal oxides, especially iron oxide. In goes the silica sand. Now I'm running a little low on borax, so I'm gonna use this other flux here. It has a lot of borax in it and a little bit of oxidizer. I'm gonna add in 325 grams of that. Actually, a little bit more. I'm gonna go with 400 because the oxidizer shouldn't actually count. It's not really a flux. It's just delivering oxygen to the smelt. The borax will also do a good job absorbing oxides and make the flux and the slag really fluid, so the metal can rain down to the bottom and collect in our collector metal. Now there probably is enough galena in here that we're gonna reduce to lead that will act as a collector metal for all the small amount of gold we have in there, those little tiny gold particles we're trying to get. But just to be safe, I'm gonna add in some bismuth oxide, which is also gonna act as a collector. I'm gonna add in, let's say 50 grams, somewhere in there. Now we'll have to do the smelt in 2 stages. As the charge heats up and melts, that oxidizer is gonna go to work and it's gonna start releasing a bunch of oxygen and it's gonna oxidize those sulfides. But at the end, we want to collect the bismuth and the lead down to the bottom. That's gonna act as our collector metal. So once that oxidizer is done, I'm gonna add in iron in the form of a coiled up iron. It looks like a spring, but it's just an iron wire. And that iron is gonna replace the bismuth oxide and the lead oxide, and it's gonna reduce those to metal that will collect our gold and silver, and it's gonna oxidize the iron. So the iron's gonna get eaten up and all the lead and bismuth is gonna rain down through and collect our gold and silver. Lid on this, shake it up real good. Sure is nice when it's dry. When it's wet, it's kind of a pain. These little lumps, they'll decompose, I hope, during the smelt. I hope. So let's get this pouring into a crucible. This is a number 10 crucible. I'm hoping all this will fit in there with enough room for the oxidizer. Oh yeah, perfect. Usually want them about half to 3/4 full. So that's maybe half or a little bit more. And as this thing heats up, gases will be released, and sometimes it foams and bubbles, so it'll gain some volume, but that should be plenty of room in there for our smelt. We'll put it in our sad little furnace here. The tricky thing about doing these smelting experiments is I don't know if that one's gonna work until I cupel the bead at the very end. It's gonna take another hour or two. And so I don't wanna just start with another of what I just did just in case it doesn't work. So now what we're gonna do is we're gonna go out to the shaker table here where we ran our samples, and we're gonna get some of the number 3. What we're smelting now is the number 2 panning tailings. I panned out all the gold out of the number 1 and number 2, and that's what's left over. This stuff here is the number 3 that comes off the shaker table right here. And this will be a significant amount of sulfides. There should not be hardly any free gold in here. But we're gonna try a batch of this next to see if there's any gold in here. Well, on the surface, that worked out really, really well. We got our 50 grams of bismuth back. It looks like we pretty much oxidized off all of our lead, which is great because we really don't want any of that lead in there anyway. The reason why I had to make sure it was really, really cool is because if you do get any lead and bismuth together as an alloy, the melting point of that thing is really, really low. And I've tipped over the cone mold many times and had liquid metal running all over the place. So you got to get that thing really, really cold. But now it's in that hot cupel in the cupelling furnace. The bismuth is going to oxidize away and be absorbed by the cupel, and the precious metals are going to be left in a precious metal bead, just the gold and silver, once it's all complete. So we'll check back on that in a little bit, but now let's go pour our number 3 concentrates and see if we have any gold in those. Another really nice pour with that second pour. So I've shut everything off. We've got the bead in the furnace there, the first one. We'll let that one cool in the cone mold. And I don't want to do much more until we figure out how much gold we got, so I'm not wasting my time and materials. So now we wait. Here's a look at the slag from our first pour. And I wanted to show you, let me see if I can find a good piece here. Here's a good piece. There's a little white flecks in there. That is larger pieces of quartz. Those are larger pieces of quartz. Here we go. Hold on, I'll get a good piece for you. There we go. See those bigger white flecks in there? Those are large pieces of quartz that didn't get eaten up by our flux. And so you can't throw in big chunks of rock into your flux because they just don't have the large enough surface area to get all dissolved. And so we're talking about pieces, you know, something like this, kind of small pebble size, pea gravel size, something like that. So that's why you got to crush up your stuff, so you don't get big chunks of stuff that doesn't get worked into the flux. You want your flux to be all nice and fluid. I'm not terribly worried about it for this. There's such an insignificant amount of quartz stuck in there, and I don't think much of it has gold anyway, so I'm not terribly worried about it. But if you wanted to, you know, smelt down a bunch of rock, you have to crush it first. You have to crush it. The ideal size is about 20 mesh minus, I would say. And then you let that go in the smelt for 15, 20, probably 30 minutes. It takes about 20 minutes to heat up, and then let it run for another 10 minutes, and you'll have a nice, even, uniform, glossy slag and the metal button at the bottom. All right, here we go, number 2. Okay, no liquid metal, that's good. Hard. A little smaller bead. That's okay. It looks nice. Let's see what that weighs. It's pretty small. I'm going to guess 15 grams. 23. All right. We're going to do a couple things here you're probably not supposed to do. Our bead is done. I'll pull that guy out. Pull that bead. Put this one in. This is our second one. Put that back in. Okay. We're going to reuse that cupel. you're not really supposed to do, especially if it cools down too much, because they can crack and then your gold runs out. But there's our gold. Let's go get it weighed. It's really yellow. It's really nice and yellow, which is surprising because on the previous video, it was about 60-40, 65-35 gold to silver. This looks like it's more like 80% plus. So let's have a look here. Okay, here we go. Oop. It's 3/4 grams. So there's probably 0.6 roughly grams of gold in there, which is about $90 at today's price. There's almost 3 more smelts worth. I did 500 grams, there's 1,350 grams there. So in theory, there's, what's that? I don't know, I can't do the math quick. 2 to 3 grams worth of gold, which would be $400 to $500. And I think that would pay for the day. So I'm gonna mix up another smelt. I'm gonna try and get them down to 2 smelts. So I'll probably do about 675 grams of ore concentrates, smelt it down, do the next one, combine both beads into our cupel, and cupel away and see if we can get our roughly 3 grams of gold, 2 grams of gold, somewhere in there. Somewhere in the middle of that, I will check on that bead that's in the cupel now, and we'll see about our number 3 cons. All right, here it is. We'll shake it up and get it in the furnace. All right, I wanted to do a little math here to show you where we're at. This is the number 1 and number 2 panning tailings. Had about 0.6 grams of gold in 500 grams of material. That ends up being 1,200 grams per metric ton, or about 40 troy ounces. The number 3 cons had about 0.1 grams of gold in 500 grams of material, 200 grams per ton, or about 6.5 ounces per ton. So we'll have to see what we end up with in our next 2 smelts, and then we'll combine all the gold. But by my math, we're looking somewhere between 2 and 2.5 grams out of almost 2 kilograms of material. And I can tell you right now, I wouldn't smelt anything less than about 1 gram of gold per kilogram of concentrate. So that's kind of the floor, and I think that's right about where we're gonna be at. The number 3 concentrates at 200 grams a ton, it's not even close. You can't even come close to making money. I think for each one of these smelts, it probably cost me about $50. That's kind of throwing a dart. That's flux, crucibles, KO wool for the furnace, propane, all that stuff. That's not including my time. So at the end of this whole thing, we'll do kind of a back of the napkin estimate on how much time and money I have involved in this and how much gold I got out. And then we can figure out how rich your material needs to be to smelt it down and make money. All right, here's our last one. Kind of pushing it a little bit with temperature. Let's see. Ah, good. They're all coming out pretty uniform, so that's good. Got a bunch of junk on the top of this one. I think that's sticking on there because it was real hot still and it's being a little bit of a pain. So I'm just gonna go put it right in the cupel with the other one. Let's see how much it weighs first. Yeah, right about 58 grams, just like the other one. So I'll go put that one in the cupel with the other one that's like halfway done, and then we just gotta wait for chemistry. All right, let's see what we got here. Oh yeah. There we go. I remember this was both of our last two smelts combined. Let's see, can I get it with these? These don't work very good. Come on, you bugger. Couple little blebs of gold around there too. Looks like it may have splattered. We'll get that cleaned up and weighed. Nice little bead. All right, so this one was about 0.75 grams, and this is a little more than 2 times that. So this should be about 1.6, 1.7, somewhere in there. Hey, 1.642. So what do they all weigh together, these two? What do we say? 2.4, okay. Let's go do some math, figure out if I made any money. All right, here's our math. I'm not gonna go through it all, but it works out to $25 an hour is what I made by smelting 1,000 grams per metric ton material. So did I make any money? No, not really. But what I did find out is that there's enough gold in the number 2 panning cons that I should just smelt all the number 1 and number 2 together. And I also found out that if your stuff is running about 2,000 grams a ton, it's probably worth it to smelt it down and get that gold out. So thanks everybody for watching. We'll see you in the next video.